Hello. It was requested that I record a demo of the sort of final presentation for CS430, so I decided to do one on Forth, which is a language that we didn't really cover in class. You can ignore the JMU logo and the labeling and everything. That's just the setup that I have in OBS, and obviously you won't have that during your presentation. So Forth was a language that was designed in the early 1970s at the National Radio Astronomy Observatory. It's a procedural language, like most of the ones we talked about this semester, and it's stack-based, which has some interesting ramifications that one of which I'll highlight for my one cool thing. The primary users were embedded systems programmers, mainly in the 1970s and 80s. This language was often used to bootstrap new hardware, so the really famous Intel 8086 chip had Forth as its first resident program. It was designed to be simple and extensible. There was this central dictionary that mapped words or names to compiled programs and or subprograms and data. Forth was often what's called self-hosting, which means that it can compile itself with only hand-coded fetch and store operations, which is why this was often used to bring on or to start work on new hardware. So here's a hello world program in Forth. So the CR word prints output with a new line, so that CR stands for carriage return. So there's the carriage return, and then there is a quote delimited string, which is opened using the dot quote operator. And then below is an example of how Forth was often used to have smaller words that were then used to define larger words. So the idea was that your programs would be very, very modular, and that each particular word would be pretty short and composed of other words. So it was really a system that was based on abstraction. So the one cool thing is that because of its reliance on the stack, most expressions in Forth are actually written in postfix notation. So 25 times 10 plus 50 is a mathematical expression, and here's how it would be written in Forth. So you have the 25 and the 10, and those would get pushed onto the stack, which you can see in the diagram there. The multiplication word would pop those two things off the stack, do the multiplication, and then push the result back onto the stack. Then the 50 would get pushed onto the stack, and then the plus would add those two, the two things that are on the top of the stack, and then return them. So that's an interesting implication of it being a stack-based language. Thanks.